So for our serial interface connections, it's going to be a little bit more complicated. Again, we have 4 of them. We should also be considering the servo, phase, and enable that are going to have to be connected as well. So to do all of this, we'll probably require some trial and error. Unfortunately, that's just part of the game. So don't be frustrated if you have to keep on redoing some routes. I've spent hours and days doing some routes, maybe not on a board like this, although it did take me quite a while to do this. But other more complicated boards will surely take much longer. So let's go ahead and get started. We can do our serial clock. A lot of these are going to be kind of crossing each other. So before we dedicate one full connection, we'll kind of get a look at all the other ones as they get closer and closer and see where we have to route them as we finalize their positions. So even though we're only concentrating on the serial peripheral interface, we're also going to route the servo and the enable and the phase connections as well. And we'll see how things go. We may connect them first, but we're still going to be all routing them through here to make the servo connection, and then the phase and enable connection as well. And that's why I said earlier we may have to push everything here a little to the left to make room for those connections as they'll be going through here. But the idea is, while we're routing things like along the wall, for instance, is we're going to want to keep the ground plane as continuous and uninterrupted as possible. So sometimes doing this makes it easier. And if we do have to make any vias across here, for example, which we'll have to probably do with the 5 volts, then at least if we're making any sort of via or interruption in the ground plane, it's as small as possible. Continuing mission. Alright, so like I said, we're going to need to make this 5-volt connection through here. So let's go ahead and do that so we can know how much closer we can push some of these pins to the via that will appear here and these pins. So we'll route 20 mil. Now we can massage these a little bit closer, not required to, but I think it looks a lot nicer. Find some wire stubs along the way. So now we need to think a little bit about how we're going to approach the next connections. So if we look at serial clock, we need to connect it here. But if we look at master in, slave out, it needs to make a connection here. So serial clock needs to go around this somehow. Let's make MISO the straightforward connection, and then serial clock. Let's see, MOSI, so it needs to be connected here. So we're kind of hosed from going another route. We may can do that, but it looks like we can squeeze right through here, just past the reset and make it in there. And then servo, enable, phase are all going to go this way. So let's make those connections. That looks good. I want to make this ground as big as possible. So what I'll do is I'm going to actually push these up. So the capacitor should be as close as possible, but it should be fine. We'll see, maybe we can make it closer. There we go, so it's kind of making our ground plane take up more of the space. I mean, of course, we'll have servo, enable, phase go through as well, but again, we're maximizing as much ground here. And it's especially noisy for this 6-volt regulator, as it will get very hot. So if we can move this a little bit closer. It's okay if the T keep out and the top is overlapping, as long as we don't get a DRC error. So that looks perfect. Let's just finish this 5-volt 10 mil route. Looks good. We can even push these out more if we choose. Alright, so I kind of like this snaking path sort of thing we got going on here. I think it looks really nice. It kind of keeps them close. And also, this is what I was trying to say, is we made this bridge as small as possible by doing that. Arguably, we could probably route another joint here, and they could have made it a little bit smaller, but we'll let this one go this time. So let's finish our routes through here. We're going to hug along the walls so we can maximize any of the ground that will be generated here. And similar to what we did with the serial peripheral interface, we need to think about how are these going to be connected. So let's look at servo. So unfortunately, this is on the end. Maybe we could have done a pin change, but this will work just fine. But we're probably going to need a via and then dive into here. We need to navigate these guys through pins, but it looks like we're kind of limited. Also, if we put these through here, we would be interrupting this potential ground plane that we would be missing out on. So we'll take the hit here and do a via. And then let's finish with the phase in enable. If we see we have 5 volts, we could bridge through here, but we'll definitely be destroying any ground plane we make. So our best 5 volt connection, well, we need to make one here too, is to do the Bluetooth, make the connection here, or maybe we'll make it through the microcontroller. Yeah, I think we'll probably do that. Looks like we have a nice path here. So it looks like the 5 volt will probably go around the edge and down through here. So we're going to need to make room here. Probably going to end up having to push everything over a bit. So before we finish this, let's rip it up, go back a little bit, and we'll revisit that. So it might seem kind of weird or annoying that we're kind of flip-flopping everywhere, but this is how you're going to have to think about things. We could have been a little naive, and the only reason why I know is because I'm trying to mimic the same board, but we could have routed these, and then we probably would have had to rip up some of them or move it later to make room for the 5 volt. So we're saving a little bit of time, and also kind of just, again, showing kind of the steps or the process by which we go around designing it. Alright, so our 5 volts, we're going to need a via through this. And I just missed something. We can change the drill size of our vias to 10 mil. Oshpark allows us to make them that small. So these will get a little smaller, which is nice, which means that we can move them a little bit closer. Technically we can move this a little bit closer then, and then all of these can follow in suit. Alright, back to this. Route from the bottom, via to the top. Make it as small as possible. And then we'll make a branch here, one to go to the Bluetooth, the other one, which is going to go on a pretty long journey, again along the edge of the wall, so we can save our ground plane. Oh, as soon as we got a little stuck here, we need to move a little bit of everything over here. Should be enough. Careful, some things may have shifted around. Looks like just this guy and this guy. Okay, everything else looks good. If something comes up later, we'll fix it. So we have our 5 volts. Let's continue mission with that. We should be able to squeeze through now. Perfect. We are going to connect it to the capacitor, but we'll run past it and run it all the way down here. Yeah, we definitely need to move the servo and the 6 volt regulator over, and we'll do that in just a moment. Let's finish the connection here. And now this guy, before we make too many more connections, let's move it over a couple ticks. We'll make some fake connections here to make sure that we can fit both wires. Yep, we can't fit through it yet, so let's move it just a tad bit more. I think that should be close enough now. Probably do real connections here. I'm pretty sure it'll fit. Move this guy down. Alright, so let us do those signals in a second, but let's make sure these are in the final position. So we'll have this guy be as close as possible to the IC, and we'll route 10 mil to it. We can route 10 mil to this as well, and then we will make the appropriate connection in just a moment. We want to finish with the signals, and it looks like it's going to get in the way, so we're probably going to have to via the 5 volts under it, which will be alright. Continuing mission, let's do the signals here. I'm going to actually push it a little bit from the ground here, because when we do rats, we want this to have a nice connection. And we might even want to move the servo a little bit more so that this has a nice connection here, but we'll see what it looks like later, or if it's even worth doing it at that point. Probably won't help too much. And then the 5 volts down with a via, up with a via. We make it close. Looks like it's yelling at us to put it out here. It's crossing the DRC there. So we'll just move this down a little bit. Massage these up, reposition this guy, and we'll try again. We could probably make this a little bit shorter if we did another joint here, but this should be fine. It's not going to be that big of a deal. And let's finish the connections, or fix these ones first. Now finish the 5 volt connection. If you notice when we did a rat's nest, this ground is a little broken up, so let's actually push everything a little bit down. You don't have to, but it really bothers me that this isn't continuous here, so I'm going to move it down a little bit. That looks fine, so let's make the appropriate fixes. That looks good to me. And then we kind of save this ground plane. I'm not going to do it, but if I was really meticulous, I'd probably move this whole thing over again, 1 or 2 more ticks so that these were aligned, and then this would be a nice ground connection, but it should be fine. It looks like the thermals were turned off on this anyways. Alright, so we're getting very close to the end. There's a few more power connections we have to do, but it looks like we knocked out all the signals. Before I send you guys off for the next one, let's fix this. Alright, looks good. Even same as on the ground plane, would have cut it right there, right here, which would have made this small, but now we made it a little bit more open. Alright, so let's see what we have to do next.